So logarithms were first brought to us by this guy named John Napier. He was a Scottish mathematician. And he actually first created them sort of as a cheat sheet. It was for, it was like a list of multiplied big numbers, and those are kind of logarithms. So he's the one who first brought us logarithms, and they're really useful because they help us write numbers that get bigger and bigger in a way that's not terrible. For example, the Richter scale is actually in logarithms. So is the pH scale. So if you ever look at that, that's actually expressed in logarithms, because otherwise the range, it starts really small and then it gets really, really big. So if you remember any of the times we've tried to graph where our range has been really large and then the graph kind of looks messed up, logarithms basically fix that for us. So the definition of logs, if you let b and x be positive numbers where b is not equal to 1, the logarithm of x with base b is denoted by log base bx and is defined as the follows. So it's log base b of x equals y if and only if b to the y equals x. So this is in our exponential section because essentially it's a way to express an exponential number. So if you notice here, the base, denoted with this b, that's the thing in the exponent that holds up the exponent, and it's actually the base of your logarithm as well. The one backwards thing is that your exponent is the answer for a logarithm. And then the answer for your exponential function is the inside of that logarithm. So the expression log base b of x is read as log base b of x. So the first thing, and honestly the main skill I want you to walk away with today, is that you can rewrite something that's in exponential form as, something that's in logarithmic form as an exponent. So example 1a, we're given the log base 2 of 8 equals 3. And I want you to rewrite this as an exponent. So again, this is your base. The answer is the exponent. And then this is the answer to your exponential. So you have 2 to the third equals 8. And you can sort of verify these two. So if for some reason you had incorrectly put 2 to the 8 equals 3, I think hopefully we would say, ooh, that can't be right because 2 to the 8th is definitely not 3. So that's one way to check yourself. So really the important thing is you remember that the base of your logarithm is the base of your exponent. So you have a whole handful of these problems on your Go Formative, and you're going to enter this whole expression if it asks you to rewrite the logarithm in exponential form. Any questions about that one? All right, let's take a look at another. So part B, we have log base 4 of 1 equals 0. So again, you start with your base, that's that 4. This is your exponent, so it's 4 to the 0 equals 1. Again, if for some reason you had flipped this and said 4 to the first equals 0, hopefully a little, alarm in your head would go off and say, ooh, 4 to the 0 or 4 to the first is not 0. Any questions about this one? All right, so part C, this one looks kind of funny. We have log base 1/4 of 4 equals -1. So these ones get kind of funnier looking. So this is your base. We usually write our fractions upright instead of sideways, but when you see them in a logarithm, sometimes just in terms of like the formatting, they'll just put it like a sideways fraction instead of an up and down fraction. Kind of depends on whoever wrote the worksheet or the notes, whatever format it is. So you can write this as 1/4. We should have parentheses because we're raising the entire 1/4 to the -1 in order for it to be 4. So this is a weirder one. When you have a fraction in your base, you'll need those parentheses because if you don't have the parentheses, it's sort of like saying 1 to the 4th to the -1. Really, that -1, is that just on the 1? Who knows? So that's why you need the parentheses there, because it's on the entire 1/4. Any questions about that one? Okay, so this is when you're asked to rewrite the equation in exponential form. Example 2 wants us to evaluate the logarithm. So now we're actually going to get a value. So you're going to do this at first without using a calculator. So the steps for without using a calculator, unless you're really good with logarithms, you're probably going to have to put it in exponential form. How did I spell exponent? Jeez. Exponent. Spelled it like a crazy person. So example 2a, we have log base 4 of 64. So your first step here is to write in exponential form. So remember, you start with the base, and now normally it's equal to the exponent. This doesn't have an exponent here, so let's just call our exponent x. That's what we're trying to find. Equal to 64. And here's where you kind of just have to use your own knowledge, and you can kind of guess and check here. What power do you raise 4 to get to 64? So you can kind of run through them in your head. 4 to the first is 4. 4 to the second is 16. 4 to the third is 64. So this would be 4 to the third equals 64. So your final answer here is that the log base 4 of 64 equals 3. On Go Formative, you would just enter the 3 as your answer. Any questions about that? Okay. So let's try that again. Part B, this one's a little trickier. So we have log base 5 of 0.2. So again, you can do a guess and check here. It's going to be 5 to what power equals 0.2. So now, if you remember about our exponents, the only way to make the original base get smaller is if this number is raised to a negative number. So there is an actual mathy way to do this other than guess and check. You can write 0.2 as a fraction. 0.2 is the same as 2 over 10. So like 0.3 would be the same as 3 over 10. 0.4 would be the same as 4 over 10 and so on. So this is the same as 2 over 10, which reduces to 1 over 5. So instead of 5 to the x equals 0.2, you could think of this as 5 to the x equals 1 over 5. Well, if you think about your exponent rules, the only way to get the 5 to the bottom is if x was negative 1. So 5 to the negative 1 would be equal to 1/5, which means that log base 5 of 0.2 is equal to negative 1. It's kind of a weirder one. You could just guess and check there too, but you'd have to remember that in order to get to that decimal, it needs to be a negative number. Any questions about that one? That was a weirder one. All right. Part C is also a little weird. We have log base 1/5 of 125. So again, write this as a fraction, put that fraction, write it as an exponent, put the fraction in the parentheses. Be 1/5 to the x equals 125. Okay, so we started with a fraction and it gets flipped to a whole number. So one of the thoughts you might want to have is that, okay, first of all, hopefully you know 5 to the third is 125. So if you started as a fraction and you end as a whole number, that means that your exponent must be negative. So 1/5 to the negative 3 is equal to 125. So that means that your log base 1/5 of 125 is equal to negative 3. Any questions about this one? So if you have a fraction as your base and you end up with either so if you end up with a whole number as your number, then it has to be a negative exponent, or vice versa. If you have a whole number base, but then the number up inside the logarithm is either a fraction or a decimal, then it has to be a negative exponent. This one, we have log of 36 equals 6. This one's also pretty tricky. because what it's asking is 36 to what power is equal to 6? So here we're going to have to raise it to a decimal or to a fraction. Again, you can kind of reason your way through this. We started with a bigger base and we ended up with a smaller number. So you can think, okay, well, I know 6 to the second is 36. So if I instead go 36 to what power is 6, you can think of, okay, well, that must mean that you took a square root of both sides. And remember, the square root is the same as raising something to the 1/2. So this has to be that 36 to the 1/2 is 6. And again, you can think of taking the square root of both sides, which is the same as raising something to the second power. So that means that this would be log of 36 of 6 equals 1/2. So you can have some weird ones in here. Sorry. So for example, if you had log base 8 of 2, you can think of the cube root of 2, or I'm sorry, of 8 is 2, so that means that the answer would have to be 1/3. Just remember those rules. Any questions about evaluating without our calculator? Okay, our calculator is here to save us for certain types of logs. So there's 2 common types of logs that you're going to see most of the time. The first one is a common logarithm, and it's a logarithm with base 10. So this is a common logarithm because this is the one that crops up in a lot of applications. I want to say the pH scale is base 10 as well. Don't quote me on that though. The Richter scale might be 2. So what that means is it's working with exponents where it's 10 to some power. So there's a logarithm that matches that, and that's log base 10. But I've told you again and again, mathematicians are a little lazy. So this is the one they decided to abbreviate. So if you ever see a logarithm where it does not have the base written, it is base 10. So this is our lazy, think the square root. We don't write the little 2 up there, but there is 2 up there. This is that version for logs. It's log base 10, can just be written as log. Likewise, a natural logarithm is a logarithm with base e. So we were talking about e to different powers yesterday and Monday. So it can be denoted as log base e, but more often you're going to see it denoted as ln. So this is just read as natural log. And it's base e. One thing to note here is that this is an ln, okay? It's not an in, so don't put in. It's an ln. I don't know how to write that so you know that. Capital Ln is actually something different, but just so you know, that's an L. So again, you're going to want to make sure you know that log base 10 of x is normally just written as log of x, and log base e of x is normally just written as ln of x. In fact, I can't think of a time you would see log base e of x ever. It would always be just natural log of x. So these are both in your calculator. So if you want to pull out your calculator quick. Example 3 wants us to evaluate common and natural logarithms using a calculator. You can evaluate logarithms that are bases other than 10 and e on your calculator, but it's trickier. Depending on what calculator you have, it's very challenging. So we have on our keyboard just a log base 10 and a natural log. So if you look in your calculator here, all that, it's in this first column. Okay, so it's in the first column, it's towards the bottom. So it's that, let me see, 1, 2, 3, 4, 5, 6, 7th down is your log base 10, right? And then 8th down is your natural logarithm. So example 3 wanted us to find the log of 8. So you'd type in log 8 and enter. And you should get 0.903089987. Let's round to the 3rd decimal place today. So the log base 8. My screen moved, sorry. log base 8 is equal to, oh no, it doesn't want to let me write. Tell you what. Log base 8 is not like base 8, geez, log of 8, because remember it's base 10, is equal to 0.903. So again, remember this is log base 10 of 8. We just don't write that base 10. Likewise, part B is a natural log. So technically it's log base E of 0.3. Again, this is on your calculator. So if you go to your calculator, we have natural log. It's the button right under the logarithm of 0.3, and you can hit enter. And we get negative 1.204. Is anyone getting anything different? Okay, I'm going to take your silences. No. So that means that the natural log of 0.3 is equal to negative 1.204. Any questions about these? So again, we're going to round to the third decimal place. You can just put the answer on your homework for Go Formative.